Welcome to 5.2. Geez, 6.2 homework help. Let me see if I can get rid of this. That helps. Oop, there's my arm. That helped. All right. Use the coordinate grid to find the length of each side of the triangles provided. Give answers in exact form and, where necessary, round to the nearest hundredth. Okay. Nope, sorry, that's my phone. So you're still going to need to use the Pythagorean theorem. And this time, instead of keeping them in exact form, we are going to resort to decimals. Anyway, so number 1. Find the length of each side. Well, for the straight sides, that's going to be pretty easy, right? We're just going to count how long they are. So for this side right here, it is when it's at, well, we could count either way. So it's at, we'll just count 1, 2, 3, 4, 5, 6, 7. All right, so that side is 7. Okay. Which makes sense. It goes from, this is 4. It goes from 4 to -3. So that is 7. It goes from 4. This is 4, and it goes down to -3, which is 7 spots. All right. And then the other one, count the distance here. 1, 2, 3, 4. Oh, let me do a different color. So that side length is 4. Okay. Or you could label the point. This point is -4, 0. So -4 to 0 is 4. Okay, now we just have to find side C. I'm out of different colored pens. We have to find this guy. So you're using the Pythagorean theorem. Oh, look, it says that right there. So that's a squared plus b squared equals c squared. Alrighty-roo. So what you're going to do is you're going to substitute the numbers you do know, so it's the side lengths you do know, into your equation. So I know 4 and 7. Once again, it doesn't matter. This could be A or B. This could be A or B. Okay. So I'm going to make 4 be A. So that gives me 4 squared plus B is 7 equals C squared. Alrighty-roo. Sorry, I'll quit saying that. 4 squared, so that's 4 times 4. Which is 16. Plus 7 squared. 7 squared, which is 7 times 7. 7 times 7, which is 49, equals C squared. All right, I'm going to click color coding. 16, geez. 16 plus 49, that is, I'm going to go over here. That is 65 equals C squared. 16 plus 49, 65. All right, your last step is to take the square root of both sides. Square root. Because if you take this, if you're squaring, but then you take the square root, they cancel each other out. Okay. So C equals the square root of 65, and this time they want them rounded to the nearest hundredth. So you actually have to find the square root of 65. You can use a calculator. I would, because I can't do that in my head. So the square root it is, okay, so that's going to be 8.06. Sorry, 8.06. So then you have to list all 3 side lengths. So your side lengths are 7, 4, and 8.06. Okay, let's do another one. Let me think. Okay, 1 second. I'm going to pause you. I think I'm going to do number 4. Yes. So number 4, you have to be careful. Let me zoom in a little bit. Hold on, guys. Wait, there. So for number 4, you have this little triangle. The first thing I want you to do is identify the hypotenuse. And you're going to be like, well, Miss Bailey, it's the slanted lines. Or maybe you're going to say that. Maybe you won't say that. Okay. You have to be careful. A and B make a right angle. Oh, I forgot I zoomed in. Hold on. Boop. Oh. Hold on. It's being slow. It's going to catch up to me in a second. Da-da-da. Good enough. Okay. Sides A and B make a right angle. They make a right angle. Sides A and B, they make a right angle. Okay, so look at number 3. Sides A and B make a right angle. Okay. So on number 4, where is my right angle? This is here. I need a pencil. I don't have one. I do. Hold on. Huh, maybe I don't. Okay, well, it's all right. So, is this a right angle? No, this is an acute angle. This is called an acute angle. It is less than 90 degrees. Here, if I use my protractor, oh, that's not going to be very helpful. Never mind. Okay, so then look over here. Is this one a right angle? No. What about, there's my right angle. Okay, this triangle has just been rotated. You could rotate it. Okay, this is a right angle. So this line and this line are your A and your B. So this is your C. Woo! All right, so you can find the length of, so this is C, and then you have A and B. It doesn't matter which one is which. A, B. Okay. So how long is C? We can figure out the length of C just by counting. Let's see, it's 1, 2, 3, 4. So C is 4. Oh, there. C equals 4. Okay, and then to find out A and B, you probably gonna have people are gonna do it in different ways, and that's fine. What we all need to realize is that, oh, I'm over here, my bad. A and B are equal. They're the same length. Okay, A is just, if I start here, right? 1, 2, 1, 2. So A and B are equal to each other. Okay, another way you could see that, to get from here to here, I'm going to go down 2 over 1, down 2, 1, 2 over 1, sorry, over 2, down 2, 1, 2 over 2, down 2, 1, 2 over 2. And I'm going to do the same thing to get to B, down 2, 1, 2 over 2. They are equal to each other. Okay? So, where can I go? Let's go here. If I have my equation, I'll rewrite it down here. A squared plus B squared equals C squared. Okay, so C squared, so C is 4, so C squared is going to be 16. Are you with me? C is 4, so C squared is 16. All right. So that means I have A squared plus B squared is equal to 16. Okay, but stay with me. Hold on, let me see if I can, this might be a lot of me, hold on. Oh, I'm upside down. Never mind, go away. Okay, we'll mess with that later. Since A and B are the same, they're the same length, right? We have determined that A is equal to B. They're the same length. So, really, if A is equal to B, which they are, oops, that can be, found my pen. There we go. 2A squared equals 16. If you want, you can choose a different variable if that's confusing. But these guys are equal to each other. So really, B is equal to A. So I can do 2A squared equals 16. Okay. Then we would be solving, so you would divide by 2, divide by 2. Come over here, A squared equals 8. Okay. And then you would take the square root of both sides. So I would get A equals the square root of 8, which, oh, we're supposed to change it into a decimal, which is 2.83, approximately 2.83. So that means if A is 2.83, so is B. So your side lengths are 2.83 and 2.83 approximately. Okay, does that make sense? If that makes sense, go away. If not, side A is the same length as side B. Okay, I can count 2 squares, 1, 2. On the other side, I can count 2 squares, 1, 2. Okay, they're the same length. All right. Since they are the same length, really, I could rewrite this as, let me go up here, A squared plus A squared equals 16. Because B and A are equal to each other. These lengths are equal to each other. If A is 8, so is B. Okay. So another way to write that is just 2A squared equals 16. And then, yeah, divide by 2 like we did down here. Oh, like we did down there. Okay, so that's number 4. Okay, so for 5 through 7, well, let me turn this off. Can I turn this off? Never mind. We'll just point it that way. For 5 through 7, you are graphing a line parallel to the given line. Actually, I wonder if it helps. Okay, so the first thing you want to do, actually, we'll go over this first. So parallel lines have equal slopes, right? Parallel lines have equal slopes. Their slopes are the same. Jeez. So what I'm going to start out doing is I'm going to find the slope of this line. You'll just zoom in a little bit. That'll help. Yeah, that's better. We're going to find the slope. We're going to find the equation of this line. All right, so when I'm talking about line equations, generally I'm going to use y equals mx plus b. Okay, so let's look at number 5. B is my y-intercept. Oh, you can't see it. B is my y-intercept, which is right here. So B is equal to -2. All right, we have that part of the equation. B is -2. So we just need to figure out our slope. You can do so by picking 2 points, but I'm just gonna use the graph. So I'll start here. It looks like we go up 1, 2, over 1. And there's another point. I went up 2, over 1. Up 2, over 1. Up 2, over 1, up 2, over 1, forever and ever and ever. So our slope is, we went 2 over 1. So our slope is 2 over 1, which is just 2. Okay, so our equation for the given line, which we write right here, is y equals my slope, which is 2x, and then my y-intercept is that -2 minus 3. Okay, so your new line, it has to be parallel. So it means your slope has to be the same. So it's going to be y equals 2x, and then you can make the y-intercept be whatever you want. It doesn't matter. Well, okay, it does matter. Don't make it -3 because then they would be exactly the same. Anything other than -3. I'm going to make my y-intercept. You can choose anything. Anything except for -3. I'm going to do 2. So my y-intercept is going to be 2. Okay, but it doesn't matter. You could have picked anything on the y-axis except for -3. All right, then my slope is 2. So I'm going to go up 2, 1, 2, over 1, up 2, over 1. And then let's go the other way. So we go the opposite, right? Down 2, left 1, down 2, left 1. Oop, down 2, left 1. Okay, let me get my ruler. I don't have one right here. Let me a little bit the other way. There we go. Okay, there we go. So same slope. Okay. If you're good with this, if you're good with parallel lines, move on. If not, I'll do another one. I'll do number 7. Just, I don't know why. So we'll do number 7 together if you want to. So your first thing is you're going to find the equation of the given line. So y equals mx plus b. I'll rewrite it. You can't see it. There we go. Y equals mx plus b. Okay. So my y-intercept is what? What's my y-intercept? It's 1. B equals 1. And then my slope, let's see, I'm going 1, 2, 3, 4 over 1. Looks like I'm going down 4, 1, 2, 3, 4 over 1. Yeah, down 4 over 1. Let's see if that checks out. 1, 2, 3, 4 over 1. Yeah. So I'm going down 4, 1, 2, 3, 4 over 1. So my slope is, I'm going down. See how my line is slanted down? It's decreasing, so my slope is -4 over 1, which is just -4. Okay, so now you can write your equation of this line. Y equals your slope, which is -4x, and then your y-intercept, or the y-intercept, which is 1, which is right here. Just 1. Okay. So parallel lines. Your line also has to have a slope of -4. Parallel lines have the same slope, but then you can choose your y-intercept. Just don't make it 1 because they would be exactly the same line. I'm going to do how about -2? Oh, I'll do a different color. Although I don't know if you can tell. My y-intercept will be -2 minus 2. All right, remember you can choose any y-intercept you want, as long, just don't choose 1 because then it would be the same. So my slope is -4, so I'm going to go down 4, 1, 2, 3, 4 over 1. And then we have to go the other way, so I'm going to go up 4, 1, 2, 3, 4 over 1. Wait. 1, 2, 3, 4. Yeah, over 1. I can do it one more time. 1, 2, 3, 4, over 1. All right, let me connect my line, or connect my dots to make a line. Right there should be fine. There. Ta-da! Okay, try number 6 by yourself. Moving on, number 8. Well, 8 through 10, now you're doing perpendicular. All right, so perpendicular. Now your slope, let me write it, I'll write it up here. So slopes are opposite slopes. So what that means, I'll come down here. So let's say my slope is 2. Okay. Opposite. Opposite means you're dealing with a sign, so you're going to change the sign. So this one is positive. Opposite means it's now negative. -2. And then reciprocals mean you flip them. So you flip it. So this is -2 over 1. So it's going to be -1/2. Okay, so change the sign and then flip it. Change the sign and then flip it. All right, let's do number 8. So our first step, once again, is to find the equation for this given line. All right, so my y-intercept is 1. Okay, so b equals 1. My slope is, I don't know, if we go up 1, 1, 2, 3, up 1 over 3, up 1 over 3. All right, so this equation is just y equals your slope, 1/3 x, and then your y-intercept, which is 1 plus 1. All right, so the slope of your new line must be the opposite of the opposite reciprocal of 1/3. It might actually be easier to do the reciprocal first. So flip it. So instead of 1/3, I now have 3. Okay, and then change the sign. So make it the opposite. So -3. And then once again, you can choose any y-intercept that you would like. I don't know. Let's just do 2? Question mark? Okay, 2. And then my slope is -3. So I'm going to go down 3, 1, 2, 3 to the right 1. And then down 3, 1, 2, 3 to the right 1. And then I'm out of room, so I'll go the other way, up 3, 1, 2, 3 to the left 1. All right. Hold on. There. Let me connect my little dots. Wait. Yeah, okay. Okay. And where they cross right here, that forms a right angle. They are perpendicular to each other. This forms a right angle. Okay, I'll do another one of these. I don't know that it really matters. I'll just do number 9. Moving on to number 9. If you got it, then skip ahead. So once again, we're going to find our equation for this given line. So our y-intercept is -1. Where can I write this? Right here. No, right here. No, I don't know. Over here. Okay, for number 9, this is number 9. Our y-intercept is -1, and our slope is 1, 2, 3, 4 over 1. Oh, it looks like it's once again -4. 1, 2, 3, 4 over 1. 1, 2, 3, 4 over 1. Yeah, so it's -4 over 1, which is just -4. Okay? we can write our equation for that line. So it is y equals your slope, which is negative 4x, and my y-intercept is negative 1 minus 1. Okay. Now, when you're writing your new line, which I'll do in purple. Hold on. Okay. Y equals. So you need to have the opposite reciprocal slope. So that means it's going to be positive because the sign changes, and then it's going to be the reciprocal. So it's going to be, instead of 4, 1/4 x. And then once again, you can pick any y-intercept that you want. I don't know. I'm kind of a big fan. I guess we can do 3. Let's do 3. 1, 2, 3. My y-intercept will be 3 plus 3, but it doesn't matter. You can choose any y-intercept. So my slope is 1/4. I'm going to go up 1 over 4, 1, 2, 3, 4. And then I'm kind of out of room over there, so I'll go the opposite way, down 1, and then left 4, 1, 2, 3, 4. All right, connect my little dots. Wait. Like that. Okay, and then these make a right angle. They are perpendicular to each other. They make a right angle. All right, try number 10 on your own. Let me get this out of the way. All right, 11 through 14. You're solving for the indicated variable. So I'll start with number 13. We're solving for x. All right, let me rewrite it and I'll color code it. I'll make x be, I don't know, probably pink. So 3 x minus 2 equals 5 x plus 8. Okay, we're solving for x. So I just rewrote it and I made my x's be pink. Okay, the first thing I'm going to do is I'm going to distribute. Oops. Going to distribute. So that I can get rid of my parentheses. So 3 times x, 3x, and then 3 times negative 2, be careful, negative 2 is negative 6. All right, there. I got rid of my parentheses. I'm just going to rewrite what's on the other side. So 5x plus 8. Now, you're solving for x. So you want to get all of your x's on one side and all of your constants on the other side. So here, I'll separate the sides. I don't know if that helps. So I want all my x's on one side. I like to have my x's over here. I don't know why, I just do. So 3x, I'm going to keep it over here, and I'm going to move 5x so it's on the right side. So I'm going to subtract 5x from both sides. Subtract 5x. Oops. So then I have 3x minus 5x, which is negative 2x. Okay. And then I didn't do anything here, so just rewrite minus 6 equals, this is now gone, 8. Okay. Solving for x, so I want this to be alone. So I'm going to get rid of my negative 6 by adding 6 to both sides. Negative 2. This is gone. And then 8 plus 6 is 14. Don't stop here. You're not done. You're solving for x. This is negative 2 times x, so you're going to divide. Oh geez, divide by negative 2. Divide by negative 2. I'll come over here. So you get x equals 14 divided by negative 2, which is negative 7. Okay, so that's number 13. Oh, sorry, that's number 11. Number 12 is very similar. Ooh, number 14 is a challenge. Try number 14 on your own, but actually 13 kind of is too. Which one do I want to do? No, I'll do 14. So we're trying to solve for y. So I have ax plus b. I'll make it a different color. Let's do green maybe. There we go. Okay, this is hard. This is harder because there aren't any numbers in this, right? You're just dealing with variables. You're just dealing with letters. So I want to get y by itself. I want to get y by itself. How do I get y by itself on this side? Well, this is b times y, so we're going to hold off on that. But I can get rid of this ax pretty easily. I'm going to subtract ax from both sides. If you want to like replace, well, it's like if I had 8x plus 4y equals 10. Okay. If you, oh, you can't see it. If you want to change your numbers, sorry, your letters to numbers, if that helps you, that's fine. Because now I'll say, okay, I'm solving for y, so I want to get rid of 8x. So subtract it from both sides, which makes this go away. So on this side, I just have b times y equals, oh, I don't know why this is purple, c minus, minus ax. Okay. If you're doing it, then subtract 8x from both sides. So you'd have 4y equals 10 minus 8x. I don't know, that might not be helping. I don't know, that might, if this is not helping you, just ignore it. So then I'm solving for y. So this is b times y. This is 4 times y. So to get y by itself, you're going to divide everything by b. So y equals, and just leave it like this, c minus ax all over b would be your answer for that. Okay? Wait. There. That's your answer. Alrighty. Good luck. Text or email me with any questions. Peace out.